Hey everyone, so I'm going to do a problem similar to your homework number 2. I'll use some different variables though. So let's write down. So there's going to be 100 depositors. That's going to be the same. And I won't change that on these questions. But the actual deposit is going to be $1,000 each. The investment opportunity, well, just like always, if you withdraw early, you don't get anything, no return. But if it's allowed to fully mature, the return is 1.25. That's the gross return. Now, the banks did an estimate. Well, it estimates that inpatient depositors can be represented by a probability of 45%. This means that there's a 45% chance that someone, when they deposit with the bank, is going to have a liquidity shock and withdraw their money early. And they estimate that the patient depositors will withdraw, let it full mature in time period 2. So this is time period 1. And this is in time period 2. All right, so what does the bank offer? Well, the bank's going to offer 1.06 if they withdraw early. What we need to find is what they will pay out to depositors that are, that are patient, that withdraw it in the second time period. Okay. So why do these depositors use that? Well, they don't want to, take this risk of not getting anything. They want to get, at least a little bit of return. So what's going on here? You'll have the depositors deposit their money with a bank. The bank will put it in the investment. The bank is acting as an intermediary here. What does the bank get? Well, it either gets R1 or R2. What does the depositor get? Well, he gets small R1 or small R2. Okay. So we don't know the R2 yet, but if the depositor withdraws early, he'll get a return of 1.06. The bank won't get anything from this. The bank will get 1.25 from that. And so this is what we need to solve here. Okay. All right. And so we have all these assumptions and variables down. Let's do number 1. That is, we need to find R2. So let's get started here. All right. So at time period T equals 0, at the start of this, 100 depositors show up. And 100 depositors times 1,000 each. Okay, they each deposit $1,000. The bank takes this and deposits with the investment. And that'll make up the deposit base. Okay, so how much are these depositors getting? Well, 100 times 1,000, that's just going to be 100,000. All right. So your deposit base starts off with $100,000. Okay, now we'll go to time period T equals 1. And 45% of these depositors are going to experience some kind of liquidity shock. If something comes up, they need to pull their money out. They need to use it. They need to be able to spend it. All right, so 45 inpatient depositors. They show up here to withdraw their money. All right, so 45 times what? What is going to be withdrawn? Well, remember the return R1 is 1.06. So 1.06 times 1,000. This is going to equal to 1,060. Okay. So the bank's going to pay out 1,060 to each early withdrawal here. So how much total does the bank need to pull out? 45 times 1,060. This will give you 47,700. So this is what the bank will pull from the investment. So what's the deposit base? Well, remember, so the return here is just one. So this actual $100,000 investment didn't change. So it's just like pulling 47,700 from it. Okay. They're not going to earn any money on this interest here. The return for the investment's one in time period one. And so now the deposit base will become 52,300. Okay. All right, now we'll go to time period two. We have 55 patient depositors. Okay. We want to know what they're going to receive. So how do we know that? Well, we got to look and see how much money's left for the investment. All right. 52,300. Remember, this money left in here will actually draw an interest. All right, 1.25 to be precise. So that's going to leave the deposit base now at 65,375. All right, that's the new deposit base. And so this is what the bank's going to take out. Remember, this is perfect competition. So the bank's not going to get any profit, zero profits. It's going to pay everything out to these remaining depositors here. And so what do you need to do to get this? Well, you just take the 65,375, divide it by 55, and what you'll get is 1,188.64. Okay. So each of these 55 depositors will get 1,188.64. Well, so what's the return here? Well, to get the return, you just take this 1,188, divide it by 1,000, and then the return is going to be 1.19. Right? So that's the answer for the first part of this. Now, the second part, we're kind of emulating a bank run. So not just these depositors that are have some kind of liquidity shock comes up, we're going to have 30 additional, so 75 total that show up because they're kind of worried about conditions. You know, they're worried about not being able to get their money, you know, for whatever reason, similar to what happened at Silicon Valley Bank. Except in their case, you know, they had made some bad investments. The bank was in trouble. It's not like people were just running for no good reason. All right, so 75 depositors show up. So the bank now has to pay 75 times 1,060. And what will that give you? That's going to be 79,500. All right, so what's the deposit base now? Well, it's just 100,000 minus 79,500. That's going to be 20,500 in the deposit base. All right. So we want to get the earnings first. All right. Not the profit, what the bank actually earns. So the bank don't earn anything on this 79,500 that's pulled out, but it'll earn something on this remaining money here if they hold it till time period 2. So take 20,500, multiply it by 1.25, and you'll get $25,675. So what are the actual earnings? Well, you want to subtract. Shoot. 20,500 from this. And so this will give you 5,125. So that's the earnings to the bank. The bank actually earned this about investing this money in this investment. Okay. All right. Now the third part of this, what sort of deposit? Read this out. So assuming the patient depositor will be able to obtain funds from the bank, how much would he or she receive? So how much will these remaining 25 depositors receive? All right. So we'll take this 25,000, 675, divided by 25 remaining depositors, and what that'll give you is 1,025. All right. Well, so what's the return? So if you withdraw early, you get to 1.16, but this is going to be more now than the patient depositors receive. They're only getting 1.025 for the return. So it's rational to run on the bank at this point. Once this run's already started at a certain point, well, you're better off just jumping the line trying to get it out if there's no deposit insurance or anything else backing it up. And that's kind of why these bank runs, will happen. Okay. Well, what can you do to stop it? Well, to try to, replicate similar to the incentives that are going on, like with the deposit insurance or the central bank stepping in. We'll say, okay, they'll freeze the first come first serve basis, and they'll wait till everybody that wants to pull out money tells them, and then they'll calculate a tax and say, okay, this is what we're going to make sure that the people that are holding their money in here and don't pull it out are going to get what they are promised. All right. So the 25 the patient depositors, we need to determine what they need. $25 times 1,188.64. So they need 29,716 each. I'm sorry, they need 1,188.64 each, but the total of this is going to be 29,716. Now, we need to calculate the shortage from what we actually have left over. Right? But in order to do that, we need to take into account the fact that the money that needs to be remain there is going to actually draw interest. Okay, so whatever money we tax and that we have left over, this money will draw interest on it as well. So you don't need quite this much money going in, leaving time period one. So you want to correct for the interest that you're going to receive here. Remember, the interest is 1.25. So you'll take this 29,716 and divide it by 1.25. That'll give you $23,772.80. Okay, now we can find the shortage. All right, so it's 23,772.80 minus, remember, the 20,520 is what's in there after everybody pulls it out. So it's going to leave us $3,252.80 short. All right. So now find the individual tax. Well, that's just 3,252.80 divided by 75. All right, so they each want to pay a tax of $43.37. So what does this mean that people receive in time period one here? We'll take the 1,060 that they were promised, take away the tax, $43.37, and this will leave them with $1,016. Okay. Well, so now it makes sense to leave your money in there unless you really need it here. Right. So now only inpatient depositors will pull their money out. And why is that? Well, that's because R1 now is 1,016. This is less than what you get for R2, which is 1,188. Okay. And so now the people, the people that really needed the money, well, they're still going to pull it out because they need it, And so what this means is that ones that are just making a run because they're worried about the condition of the bank, they won't run, and then this will end up quelling the bank run, and so everybody will be happy. They'll get what they originally were intended to do. Now, the example of the Silicon Valley Bank, the reason it didn't work is because, well, I think like 97% of the funds there weren't covered under federal deposit insurance. It's kind of an unusual bank. Like there's a lot of people, they had their business accounts with them where they pay out their salaries and stuff like that. So a lot of them had like a really large sum of money in their banking account. Okay, so lastly here, let's use the results from this and show why did people use these banks in the first place. And we're assuming people were risk averse. We'll use our utility here. We have income on the x-axis. Utility is a function of income. And risk averse people have diminishing utility here. They get a lot of utility out of income at lower levels. But then when you start getting increases as you get to a higher and higher level of income, well, the utility goes up a smaller amount. So 1,000, well, this is the utility get if you direct investly with the investment and you pull it out early. 1,060. Well, we said that was the return for inpatient depositors that show up at time period 1. Okay. And 1,188. Well, this is for people to deposit with the bank that are patient. They wait and withdraw their money at time period 2. This is what they get, 1,188. 1,250. Well, this is what people get if they invest directly with the investment and they let it fully mature. Let's return big R2. All right, so why do these risk-averse individuals, why do they choose to use the bank? Well, they get a higher return in the bad state, but they get a lower return in the good state. Well, they prefer getting this little higher return in the bad state because the gain in utility in bad state or when there's a liquidity shock is greater than the loss in good state. Okay. That is, they want to avoid this downside risk. They want to minimize variance, right? And that's because they want to avoid this downside risk. They care about this loss here. They'd rather gain this money here instead of losing it in the bad state. It's nice to get this extra money in the good state. It'd be nice, but it doesn't mean as much to them as this loss here in the bad state. Right? This money here at lower levels of income is more important to them. Gain in bad state is greater than the loss in the good state for risk-averse individuals. Okay. The bank, it allows for consumption smoothing in the presence of liquidity shocks. So what the bank's doing here is providing a form of insurance. It's allowing these people to pull their funds and to provide insurance against these liquidity shocks. Okay. All right, so that's it. I hope this was helpful.